Hi, in this video, I want to go over chapter 4 of the math statistic, introductory statistic in OpenStax. Chapter 4 is talking about the probability distribution. In section 4.1, we learn how to recognize if a distribution is a probability distribution. In 4.2, we learn about finding the mean and the standard deviation of any probability distribution. And in the last section of chapter 4, 4.3, we talk about the specific types of probability distribution, which is called the binomial distribution. So in any probability distribution, we need a random variable. Random variable, which we typically show by letter X, is a single numerical value, which comes, determined by chance. So something that in this sentence is important, that a random variable, it's a numerical value. That means must be represented by only numbers. And when we talk about the probability distribution, a probability distribution is a description that gives you a probability for each value of the random variable. So that means in any probability distribution, we have a random variable X, and for each value of random variable X, we have a probability. So that means every probability distribution, which sometimes represented like as a table or a formula or a graph, it usually has a random variable X and a probability of each value of that random variable. When we talk about the random variable, you know that we have two types of random variable, a discrete random variable and a continuous random variable. Discrete, as we had the definitions on previous chapters, it's a value that's finite or countable. When we have a collection of values that are finite or countable, we call them a discrete random variable. Like, for example, the number of tosses of the coin before getting the first head. So the number of tosses, it can be, just when you roll a dice to get the first head, you may just roll it once or 2 times or 10 times or 15 times. These are the value, they are countable value. You can't say I rolled the dice 10.5 times. But when we talk about the continuous random variable, it can have infinitely many values, and the values are not countable. For example, when we talk about the body temperature, it can be any number, not just some specific numbers, because we can represent it as in decimals as well. So in this section, we talk about discrete random variables. Okay, because the random variables, the X value that we represent in all of the examples are countable, are finite and countable. So let's look at an example. In this example, it says determine whether each random variable is discrete or continuous. X represents the number of Fortune 500 companies that lost money in the previous year. When it says the number of companies, it can be 1 or 2 or 3. It can be numbers, some finite numbers, some countable numbers, from 1 to 500. We can have 1.5 companies. So that means this is a discrete random variable. X represents the volume of gasoline in a 21-gallon tank. Okay, the volume of gasoline in a 21-gallon tank. So for sure is a number between 0 to 21. But the question is, are only finite or countable numbers, or it can be any number? When we talk about the volume, it can be any number from 0 to 21. Even the numbers between 0 and 1 gallon, 0.5 gallon, 1.75 gallon, 2.63 gallon. So since it can have any number, it's called a continuous random variable. Now, what are the requirements to have a probability distribution? For any probability distribution, we need to check these 3 requirements. If it satisfies the requirement, we can say, okay, that's a probability distribution. First of all, we have to have a numerical random variable. That means the random variable x must be represented by numbers only. Second, any probability in the probability distribution must be a number between 0 and 1, like any other probabilities. We know that the probability is always a number between 0 and 1. And you know we mostly represent the probability distribution by tables, and the tables include the random variable x and the probability for each of those values in random variable. So we say x values must be numbers, probabilities must be numbers between 0 and 1, and the last requirement is that the sum of all probabilities must be 1. So when you add all of the numbers in the probability column, they must add up to 1. If you get any number less or more than 1, you don't have a probability distribution. So that's very important requirement that we always have to check. For example, it says this table lists countries along with the proportion of unlicensed software in each country. Does this table describe a probability distribution? Okay, we need to check the requirement. The first requirement says that the random variable must be numerical, must be number. And the random variable in this example is the name of the countries. These are the random variable x. And these are the probability or the proportion in each country. Are the random variables numbered? No. So as you see, it doesn't meet the first requirement because random variables are not numbers. If I want to check the second requirement tells me that each probability must be a number between 0 and 1, and as you see, they are. And the third requirement says that the sum of all these probabilities must be equal to 1. And if we add all these numbers, we see 64 plus 58, it's already more than 1. Even if we add the rest, we get a number for sure more than 1. So it doesn't meet the third requirement as well. So this table do not satisfy the first and the third requirement. Random variables are not numbers, and the sum of probabilities is not 1. So we say no. This table does not describe the probability distribution. Let's look at next example. We have another table which is for a 3-day forecast and the number of days of rain and the probability for each of those values. Let's check if this describes a probability distribution. So first of all, the random variable, which is the days of rain in that 3 days, 0, 1, 2, 3. Okay, they are numbers. So yes, it meets the first requirement. Second requirement, each probability must be a number between 0 and 1. And as you see, they are. And the third requirement says that the sum of all these probabilities must be a number, must be equal to 1. So now we only have to add these 4 numbers, 0.216 plus 0.432 plus 0.288 and plus 0.064. And we see that they add up to 1. And we can say, yes, this table describes a probability distribution. Next example, we have a table, random variable x, the probability for each of the random variables. So as you see, the first requirement, all of the x values are numbers. Yes. The second requirement, the probabilities are numbered between 0 and 1. Yes. And the third requirement says that if you add all these probabilities, if you add all these numbers, they must add up to 1. Are they? Let's see. If we add all these numbers, they add up to 1.07. So the answer is no. This table is not a probability distribution because they must add up to 1. Next example, it says suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days, 15% of the time, 1 day, 4% of the time, and no days, 1% of the time. And suppose 1 week is randomly selected. That means the random variable is the number of days that Nancy attended class in a week. So when it says let x equal to, that means describe what the x is. X is the number of days Nancy attended class in a week. Now the question is, what values does x take on? What values the x or the random variable can have? So when you read the question, it says, Nancy attended class 3 days a week, or 2 days a week, or 1 day a week, or no days. So these are the numbers that x can have. That means x can be 0, that means Nancy do not attend any classes. 1, attend only one day. 2, attend 2 days a week. And 3, attends 3 days a week. And it says, suppose 1 week is randomly chosen, construct a probability distribution. And we also show the probability distribution with a PDF. PDF means the probability distribution function. And we want to show the PDF table. Okay, in any PDF table, we need a table for x and probability of x. X values can be 0 or 1 or 2 or 3. Now the question is, what are the probability? What's the probability of attending class 3 days a week? 80%. So, but we never show the percent in when we talk about the probability. We should always show with the decimal. 2 days a week, 15%. 1 day a week, 4%. And no day, 1%. Excuse me. And now we have a probability distribution table. Let's look at next example. It says a baker is deciding how many batches of muffins to make to sell in his bakery. He wants to make enough to sell to everyone and no fewer. Through observation, the baker has established a probability distribution. And you see the table. Okay, define the random variable x. What's the random variable x? What are those numbers? 1, 2, 3, 4 represent what? And it says it wants to make sure that have enough to sell. So that means x values are the number of muffin that the baker sells. So that means 15% of the time he sells 1 muffin, 35% of the time 2 muffins, 2 batches of muffins actually, 40% of the time 3 batches of muffin, and 10% of the time 4 batches of muffin. So x, define the random variable x. X is the number of batches of muffins that the baker sells. Now, what is the probability that the baker will sell more than 1 batch? More than 1 batch, that means the probability of x more than 1. X more than 1, if you look at the table, X values, the random variables, can be 1, 2, 3, or 4. When it says X is more than 1, that means X can be 2, or 3, or 4. And you know, whenever in a probability topic, I say or means add. We learned this one in chapter 3. So or always means add. When I say the probability of x more than 1, that means I need the probability when x is equal to 2, or then find the probability when x is equal to 3, or probability when x is equal to 4. So I need to have the answer for the probability of 2, 3, and 4 and add them together. And I have those numbers. So 0.35 must be added by 0.40 and must be added by 0.10. And as you see, the answer is 0.85. And the last part is what is the probability that the baker will sell exactly one batch? Exactly one means when the p is equal, when the x is equal to 1, we want to find the probability, the p of x equal 1. Okay, look at the table. When x is equal to 1, what's the probability? It's 0.15. So that's it. That's the answer. So the probability of x equal 1 is 0.15. Next example. It says Javier volunteers in community events each month. He does not do more than 5 events in a month. He attends exactly 5 events 35% of the time, 4 events 25% of the time, 3 events 20%, 2 events 10%, and 1 event 5% of the time, and no events 5% again. Define the random variable x. Okay, what's the random variable x? X is the number of times that he attends an event, right? Each month. So x represents the number of times Javier attends events in a month. What values does x take on? So when x is the number of times that he attends events, so he can attend events 0 times, that means no attending any events, or 1 times amount, or 2 times, or 3 times, or 4 times, or 5 times. And it says he does not do more than 5. So that's it. So the values of x can be only from 0 to 5. Now it's asking you construct a PDF table. To construct a table, you need a table with x and p of x. X values, the random variables, 0, 1, 2, 3, 4, and 5. And the probability for each of these values, 0 times is 5%, 1 times is also 5%, 2 events, it's better that instead of number of times, says the number of events. Yeah, I'm sorry. The number of events Javier attends in a month. Okay, 2 times is 10%. 3 times is 20%. 4 times is 25%. And 5 times is 35%. Now we have a probability distribution. In next part is asking find the probability that Javier volunteers for less than 3 events each month. Less than 3 events when the probability of x is less than 3. So let's look at the table. What numbers are less than 3 in the table for x? So as you see, these values are less than 3. Right? So that means you need to have the probability when x is equal to 0, probability when x is equal to 1, the probability when x is equal to 2, and then add them together. Because when we say the probability when x is less than 3 means it's 0, or it's 1, or it's 2. And or means add. And the answer is 0.05 plus 0.05 plus 0.010, which is equal to 0.20. Part E is asking find the probability that he volunteers for at least one event. What does at least mean? At least one means one or more. Okay, so you can say the probability of x which is equal to 1 or more. So that means counting 1, attending 1 event, or 2 events, or 3 events, or 4 events, or 5 events. When you talk about the greater than or equal to 1, or you can also say just more than 0, because when you talk about more than 0, there is no equal sign here. That means you're not counting 0. You start at 1. So they are the same. So you can represent that one as a probability when x is greater than or equal to 1, or just more than 0. But I prefer greater than or equal to because it talks about at least 1. At least 1 means 1 or more. 1 or more means the probability of 1 or probability of 2 or 3 or 4 or 5. You need to add all of them together. So you need to add all these numbers, the probabilities. And if you add them together, 0.35 plus 0.25 is 0.60 plus 0.20 is 0.80 plus 0.10 is 0.90 plus 0.5 is 0.95. So that means 95% of the time he attends at least one event each month. Now in section 4.2, we want to see how we can find the mean and standard deviation of any probability distributions. Something that it's important to remind you that all the probability distributions are description of the population. So that means when I'm talking about the mean and the standard deviation, I'm using the formulas that works for the population, and I'm using the notations for the population. So they are all parameters, not statistics, because parameters describe the population. So how do we find the mean? So we show the mean by notation with this notation for the population, which is called mu. And the mu for each probability distribution will be calculated by multiplying each x by p of x first. Then we multiply each random variable by its probability, and then add them all together. Sigma means add. This notation means add. Okay, so you multiply each x by p of x. After multiplied all of the x by the probability of that specific x, then you add them together. To find a standard deviation, which we show by sigma, we need to know the variance, because a standard deviation, as I said in chapter 2, it's the square root of the variance. So if you have the variance, you just take the root. How do we find the variance? To find the variance, like what we had in chapter 2, we subtract mean from each random variable, which x, then we square them, and then multiply by the probabilities. After that, we add them together because of the sigma. We also have another formula that we can use that says the shortcut, and it says this format is easier for when you have manual calculation. And in another video, I will show you how you can use the online calculator on Canvas and just put the numbers there and let the calculator calculate the mean and a standard deviation for you. But now in this lecture, we want to work on all of the problems manually and calculate the mean and the standard deviation. After you find the variance by one of these formulas, you just put it inside the radical and you take the square root to find the standard deviation. And it doesn't matter which formula do you use. It depends on which one you feel more comfortable using them. Okay. For the first example, we will have a probability distribution for the personality inventory test for passive-aggressive traits is given. Find the mean, variance, and the standard deviation. So to find the mean, we said we need to multiply all of the x by the probability of that x, and then add them together. That's it. So that means I need to multiply each of these x values by its probability. You can also create another column in the table to just multiply x by p of x first, write them in this column, and then at the end, just add them together to find the mean. So let's do that. If I multiply 1 by 0.16, I get 0.16. Multiply 2 by 0.22, 3 by 0.28, 4 by 0.20, 5 by 0.14. And we get these numbers. Now to find the mean, we need to add all these values. And if you add them together, it gives us 2.94. So the mean is 2.94. Okay, now it's time to find the standard deviation. So to find the standard deviation, if you remember the formula, you need to subtract the mean from each x values first. After finding them, you need to square them and then multiply by the probability, and at the end, just add them together. Find the variance actually. You can also follow all these steps in the table. So that means in your table, you can have a column for subtracting the mean from each x values. Then you have another separate column for squaring those numbers, and then another column for multiplying those squares by the probability. And at the end, we just add all these values in the last column, and it gives us the variance. So we found that the mean is 2.94. So we need to subtract 2.94 from each of these x values. So 1 minus 2.94, 2 minus 2.94, 3 minus 2.94. And you see the answers. Now we need to square these numbers. Negative 1.94, we need to square it. Square means multiply by itself. Negative 0.94 square it, 0.06 square it. And if we square all these numbers, we get another sets of numbers. Now it's time to multiply these numbers by the probabilities. Multiply these numbers by the probabilities. Multiply 0.16 by 3.7636. Multiply 0.22 by 0.8836. And if we multiply them, we get these new sets of data. Now we just need to add all these numbers. If we add these numbers, we have this variance. And if we take the square root of that number, we will have the standard deviation. And as you see, the variance is 1.6164, and the standard deviation is the square root of that, which is 1.27. And if we round it up, it gives us 1.3. So whenever you're working on these types of problems, putting all the steps in the table, it helps you to just have an organized table and find answers faster. And also it reduces the chance of making mistake, of missing some numbers or having a wrong calculation. Now, what is the expected value? Expected value means the average gain or loss in any event. Okay, which also we call it a long-term average. So sometimes you may see this word, you may see long-term, find the long-term average instead of expected value. Okay, so expected value is usually will be calculated when we have types of games or lottery. So we want to see how much is the average, gain or loss. And since it's talking about the average gain or loss, that means average means mean. That means the expected value in the discrete probability distribution is exactly the mean. So we show the expected value by letter E. So the expected value is exactly the same as mean, and you know how to find the mean of any probability distribution. And to find the mean, you need to multiply each x by the probability and then add them together. That's it. It's not a sum, it's not a new formula. Whatever we did for finding the mean, we do the same to find the expected value. But the only thing important that when we talk about the expected value, since it's usually, it's talking about the average loss or gain in a game, to x or the random variable is the net gain, how much we received, how much we gain, in that game. Not exactly, just it's not a number of times or something. Usually it's the net gain. And you need to know how much is the net gain after playing that game or after winning any prize on that game. And if you get the expected value of any game is 0, you can call that game a fair game. Otherwise, neither side has, when it's 0, neither side has an advantage. But if you get any number, a positive or negative, that means one side has an advantage. Let's look at an example. A men's soccer team plays soccer 0, 1, or 2 days a week. And the probability that they play 0 days is 0.2. The probability they play 1 day is 0.5, and 2 days is 0.3. Find the long-term average. Long-term average means the expected value. Find the mean. Same. They only just mention one of them usually. Of the number of days per week the men's soccer team plays soccer. Okay, so that's a random variable. The number of days per week that the men's soccer team plays soccer. And based on the description in the problem, it says the men's soccer team plays 0 or plays 1 day or plays 2 days. So the number that the random variable can take on is 0 or 1 or 2. And the probability for 0 is 0.2, the probability for 1 is 0.5, and the probability for the 2 days is 0.3. We can put it in a table and create a probability distribution table. So to find the expected value, we need to find the mean. And mean is, so if you remember the formula, mean is the sum of x times p of x. So I need to multiply each x by p of x first, which I did in the table, and then add them together. If you multiply x by p of x, 0 times 0.2 is just a 0, because 0 times any number is just 0. 1 times 0.5 is 0.5, 2 times 0.3 is 0.6. Now I need to add all these numbers to find the mean. And if I add them, it gives me 1.1. So which means the expected value for the number of days that this team plays soccer is 1.1. Let's look at an example to find the expected value for a raffle ticket lottery. It says at the raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. Find the expected value and interpret its meaning. Okay. Before we find expected value, we need to create the probability distribution. And the probability distribution that we make, it must have x and p of x. And since this is a game, that's a lottery, we the X or the random variable is usually the net gain. Net gain is how much you gain in that game. So you know that you may win $500 or you may win $250. You may win $150 or you may win $75 or you may win nothing, $0. These are all the different cases that we may have. But when you win $500, is your net gain $500? Is all you receive? No, because we already paid $2 to start the game to buy the ticket. So when you pay $2 to buy the one raffle ticket, that means even if you win the $500 prize, your net gain is $498 because you already paid $2. Even if you win $250, your net gain is $248. If you win $150, your net gain is $148. If you win $75, your net gain is $73. And if you win nothing or $0, your net gain is negative $2 because you still, you lost $2 to buy that ticket. So that's negative 2. So these values are the net gains, are the X values. So these are the X values. Now, when you want to create a table, you need X values and a probability. Now we need to calculate the probability of winning each of these prizes. So how much is the probability of winning a $500 ticket? How much is the probability of winning $250 ticket? How much is the probability of winning $150? How much is the probability of winning $75? How much is winning nothing? Okay. The probability of winning each of these prizes, it depends how many tickets we bought. So we have only one ticket out of 1,500 tickets. We have one ticket out of 1,500 tickets that are sold. So that means the probability of winning each of these prizes is 1 over 1,500 because you have only one ticket out of the 1,500 tickets that are sold. Okay, now what's the probability of winning nothing? So you know that 1,500 tickets sold and you have only 4 chances of winning a prize. So that means the remaining is the chance of winning nothing. So out of 1,500, if you subtract those 4 prizes, that means you have for 1,496 over 1,500. That's a probability of winning nothing. Okay. Now we have all of the X values, we have all the probability values, and to find the mean, we need to multiply each X by its probability. Multiply 498 by this fraction, 248 by the fraction, 148, 73, and negative 2. And if we multiply them and add them together, we get negative $1.35. The expected value is negative 1.35. When the expected value is negative, is it a fair game? No, for sure it's not. Only time the game is fair when we get expected value of 0. This game is not fair. And when you get a negative as an expected value, that means for every one ticket that you buy, you have a chance of losing $1.35. For every $2 that you spend to buy a ticket, you can expect to lose an average of $1.35 for each ticket. Another example about this topic is that suppose you play a game of chance in which 5 numbers are chosen from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. A computer randomly selects 5 numbers from 0 to 9 with replacement. You pay $2 to play and could profit $100,000 if you match all 5 numbers in order. And it says you get your $2 back plus that $100,000. That means this sentence tells you if you win the prize, that means your net gain, that's exactly $100,000 because they give you back the $2 that you already paid. So you're not losing anything for buying any ticket or just participating in the game. Over the long term, what's your expected profit from playing the game? Okay, so we need to create a probability distribution. And the probability distribution is a table for the random variable x and the probability for the random variable. And when you pay $2 to play the game, you only have two chances. You play $100,000 or you win $100,000 or you win nothing. Okay, so the random variables are only $2 that you pay, or actually negative $2 that you paid and you won nothing, and $100,000 that you won. So the x value or the amount of money that you profit is this one. It's -2 or $100,000. You only have two case in this problem. And now, what is the probability? Now we get back to the problem. What's the probability of winning $100,000? What's the probability of winning nothing? So the probability of winning $100,000, it says you will win $100,000 if you match all 5 numbers in order. Okay? So you select 5 numbers from 0 to 9, and it says with replacement. When it says with replacement, that means when you select one number, you still have a chance to select that number again. Okay? So you have from 0 to 9, we have 10 numbers. What's the probability of choosing the first number correct? Is 1 over 10. What's the probability of choosing the second number correct? Still, since it says with replacement, still we have all 10 numbers. That's right. So again, is 1 over 10. What's the probability of getting the third number correct? 1 over 10. The fourth number correct, 1 over 10. And the fifth number correct, 1 over 10. That's the probability of just matching all 5 numbers in order. And the answer, after multiplying all these fractions, it is 0.00001. And that's the probability of winning that prize. And how much is the probability of winning nothing? You just subtract this number from 1, because you know that in any probability distribution, the sum of all the probabilities is always 1. If the probability of winning is that number, that small number, if you subtract it from 1, you get the probability of the other one, or the probability of winning nothing, or the probability of losing. Okay, so when you play this game, you have only two chances: lose or gain. If you lose, if you win nothing, you lost the 2 money that you paid to start the game. If you win $100,000, they give you back the $2, so your profit, that's exactly $100,000. And we have the probabilities now, and to find the expected value, we need to multiply each x by the p of x, and we get these numbers as you see on the table. And we only need to add these numbers. And if you add these numbers, we get a number which is very close to -1. And that's the expected value after paying $2 to start the game. So, and how you interpret this result, and you say, okay, you expect to lose, on average, you expect to lose approximately $1 for each game you play. Okay. And the last example says a game involves selecting a card from a regular 52 card deck and tossing a coin. The coin is a fair coin and is equally likely to land on heads or tails. It says if the card is a face card and the coin lands on head, you win $6. If the card is face card and the coin lands on tails, you win $2. And if the card is not a face card, you lose $2, no matter what the coin shows. Find the expected value for this game. I recommend you stop this video and try to find the probability distribution table and see if you get the same answer. And remember, for any probability distribution, we need the random variable x and we need the probability for each random variable. And the random variable, in these cases, when we have games, it's the net gain. Okay? So that's the event. If the card is a face card and the coin lands on head, but the net gain is $6. And as you see in this problem, it doesn't mention anything that you have to pay something for start the game. So that $6 that you receive, you win, that's your net gain. If the card is the face card and it's tail on the coin, you win $2. So that means your X values are $6 or $2. And if the card is not a face card, you lose $2 or nothing, which is 0. Oh, sorry. It says you lose $2, so it's -2. Yes, you have to pay $2, no matter what the coin shows. So these are your X value. You win nothing, but you still have to pay $2. And now we have to find the probability for each case. You win $6 if the card is face card and the coin lands on head. Now you ask yourself, what's the probability of getting a face card on a regular 52 card deck? How many face cards do we have in the deck? We have 12 face cards. So the probability of getting a face card is 12 out of the 52 cards. And in any probability, and means multiply, the coin lands on head. What is the probability of getting a head on a coin? The probability of getting a head, since on a coin we have only two cases, head or tails, and head is one of those two, so it's 1/2. And if you multiply these two, you get the probability for winning $6. Second case, if the card is a face card and the coin lands on tail. If the card is a face card, still the probability is 12/52 because we have 12 face cards out of the 52 cards, and the coin lands on tail, so the probability of getting tail is 1/2, and because of and, we multiply these probabilities, and the answer is the probability of winning $2, which is exactly the same as the $6, the probability. And it says if the card is not a face card, okay, not a face card, what's the probability of getting any card not face card? So out of the 52 cards, if 12 of them are face card, that means 40 of them are not face card. So the probability of getting a card which is not a face card is 40/52. And it says no matter what the coin shows. That means the coin can show a head or tail. It doesn't matter what it shows. That means it's 2/2, which is 1. And the answer is the probability for losing $2. And if you put them in the table, you will have a probability distribution. Now, find the expected value. How do we find the expected value? We multiply each of the x values by its probability. Multiply these, multiply them, multiply, and then add them together. If I multiply 6 by 6 over 52, if I multiply 2 by 6 over 52, and if I multiply negative 2 by 40 over 52, and then add them together, as you see, all the denominators are 52. You can keep the denominators 52 and just multiply these to 6 times 6, which is 36. 2 times 6 is 12. And negative 2 times 40, which is negative 80. So the final answer is negative 32 over 52. And if you change it to decimal, gives you negative 0.62. And you see that the expected value is a negative number. Okay, so the long-term average profit is negative. That means you have a long-term loss, not a profit. Okay, should you play this game to win money? I say no, because the expected value is negative. For every game that you play, you have a chance of losing negative $0.62. Okay, I stop here, and in the next video, I will talk about the last section of chapter 4, which is 4.3, and it's talking about the binomial distribution.